In our previous video, we have completed our power section 232 and LoRa schematic. In the miscellaneous, we have nothing. We have mounting holes and feed cells. In the GSM, I have used M66 module. You can download the dataset of M66 hardware design guide and you can create your own footprint and schematic as per our previous video and make the connection. And in the MCU schematic, we are using STM32. So we have already completed our power section and now we are going to interface this MCU with other schematics. For that, we are going to use STM32CubeMX. You can log into stm.com and you have to sign up, and then you have to download this software STM32CubeMX. Then we are going to create some project. Go to new project, and now we'll select our controller, and the first thing what we can do is we'll go to the main section of the circuit. Just like for 232 we need 1 U-watt, so go to your QMX and then search for connectivity, then select U-short and then enable it. And now we are going to select for LoRa we need SPI lines and 3 GPIO. So we'll again come to the controller and then we'll select SPI lines full duplex mode, and then we'll also select chip signal, and now we'll add GPIO later. So first we are going to select the main pins of the devices, and now we need full control U-watt. So again go to U-watt tree and then enable CTS RTS enable. So U-watt is selected, and now we are going to use these pins to our controller first. So first we will add this one, P18 and PN9, U-short1 and U-short1 RX and U-short1 TX. So come here 10 to 32, copy it. First you can see this is U-short1, right? So we'll add here U-short1, 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 and then we'll copy it and then paste it. We'll copy it and then paste it, save it, copy it again, go to controller and then PN9 and P18, paste it, PN9 and P18. PN9 is U-short1 TX, PN9 is U-short1 TX, PN9 is U-short1 TX, and P18 is U-short1 RX. Press W key on your keyboard to make the wire connection. So PN9 is U-short1 TX and PA10 is resort1 RX, so it will be like input and it will be output. So it will send the data and it will reach to the 232, then it will reach here and then it will out, so it will be receive pin for the debug connector. Then when from debug connector, when TX will receive here, then it will receive the RX, then it will R out, then R out you want one RX to the controller side, then it will come here, so it is correct. And now we need this UART3 lines, so we'll go here to our GSM schematic and we will copy this TXT, RXT, CTS and RTS. We'll copy this and then we'll come here to the MCU and then we will use UART3TX at PV10, UART3TX is at PV10, UART3TX is at PV10, so we'll go here and we'll make our connection and place it, and then it is TX at PV10, then RX is at PV11, RX is at PV11, select this and then place here, it will be PP11, place it, PV11 is RX, and now RTS is PV1, RTS is PV1, okay. I'll make the connection. RTS is at PV1 and then CTS PV13, CTS is at PV13, okay. CTS is at PV13. So TX and RX, so TX will transmit from here and then okay, so GSM TX will come here, okay. It is a GSM TX will come here and then it will become RX, it will become RX, okay, it will become RX. So I'm just going to place it here and I'll also add some text. So PB11 is RX, PB11 is RX, user tree rx. You have to press K button on your keyboard for the text. So this is RxPB11. We can see this is user tree Rx. So when JSON will send data, it will receive to the Rx, and when MCU will send data, it will be TX. Okay, it will be TX, but it will reach to the JSM receive pin. User 3 TX PV10. User 3 TX is PV10. So it will reach to the receive pin of the JSM module. So it will come here and it will be receive pin of the JSM module. Again will come here. So RTS, it will reach to the JSM. RTS, it will reach to the JSM, and then CTS will be out. CTS we can see to the GSM, so it will be input. Okay, it is done. And now what other thing we are missing is SPI line. So we'll copy this SPI line and we need PA4 567 reach to the MCU. We need PA4 5 6 and 7. Okay, now PA4 we can see this is SPI chip select. It is SPI chip select, so we'll place here. And PA5 is SPI clock. PA5 is SPI clock. And PS6 is SPI MISO. PS6 is SPI MISO. And PS7 is SPI MOSI. It is SPI MOSI. So this is master out. So this will be out. Okay, it will be out, and it is the receive pin, so it will be input. It will be master input, and this is clock. It will be out, and this chip select will be out. Okay, PA4 is chip select, PA5 is clock, PS6 is MISO, PS7 is MOSI. And now what we can do is we need programming pins. So for that we have to select this system, debug serial wire. So for debug serial wire, PA14 is clock, PA14 is clock, and PA13 is DIO. PA13 is DIO. Net level press L on your keyboard, and this will be SWDIO, and this will be SWCLK, and label SWDIO. This will be input pin, and output pin, it will be both. Okay, and now for clock, just copy it here, and now we'll use some register. So we'll use this 22 ohm, press edit, and then we're going to add here, this will be our 22 ohm, okay, copy it, place, and now we have to move it here so that we can make our connection, and then I think we can delete this one, and we can place it just right here. Okay, okay, ground, and then VDD. What left is reset. Okay, so for reset, press L, reset, place here, okay, there is some, okay, first I have to delete this, there was no center point for that, so I'll just place it here and then reset again, reset, it is not taking center point, so okay, and now we can copy it just right here. Okay, copy it, X, copy it, place, press here, and then copy it, okay, Okay, now it is done. And now what left is GPIO pins and oscillator. So for oscillator we can use internal oscillator of the controller. So we will connect rest of the schematic GPIO lines, just like one GPIO lines I can see here. Okay, so I'll just move to my controller circuit and then connect my GPIO lines. Okay, this will be output. Okay, and then 232, there is no GPIO lines. For LoRa we have 3 GPIO lines. We'll copy it and then move to the MCU again and then paste, and we'll get this center point to make the connection. Okay, okay, press W on your keyboard to make the connection. Okay, and now it is done. So this will be GPIO input, this interrupt input, and this will be output, and this will be output. And I'll go here. So this is input, so this is output. So interrupt is input and this 2 GPIO output. Okay, and now again we'll come up to GSM and TXT RXT is done. DTR we need, DCD we need, and one power key. Okay, copy it. Okay, so I copied it, and now we'll move here to MCU. Okay, and now first we can make this connection. Okay, okay, so DCD can be input, DTR is output, RI is input. RI is input, DTR is output, and DCD is input. Okay, one power key is left. We can make this power connection. Press L, copy it, and this will be output. Copy it, move to the GSM. Okay, okay, done. And now what is left? So I think we have almost completed our entire circuit. So we can press Q to mark this not connection pin. This pin is not connected, so we will use this don't mark pin connection. This is cross pin. You can use it by pressing Q button on your keyboard, and then you can just copy it to rest of the pin which is not connected. Okay, it's done. Okay, so we have completed our schematic, and now we have to add one heading here for MCU. So what we'll do is I'll just copy it and then paste MCU. Now go to tools and then annotate schematic. So here are condition like entire schematic, yes. Short symbols by X position, yes. Keep existing annotation. Okay, so I will reset it all because I haven't moved to the PCB. So I will reset existing annotation if there will be any. So if our PCB is ready and we have added some component and our schematic is ready already, then keep your options, keep existing annotation. For now I am keeping it reset existing annotation, so it will reset every reference designator annotation if there will be any on our schematic. So I will annotate it. So MCU is ready, GSM is ready, miscellaneous is ready, LoRa is ready, 232 schematic is ready, and now the power input connection is ready. So we will also check this ground connection and power 5 volt, ground 5 volt, ground 4 volt, ground. Okay, then 5 volt again to 3 volt. So 5 volt to 4 volt, 5 volt to 3 volt. We'll come here. So this side is 5 volt, this side is 3 volt, this is ground. We'll add this don't mark condition here. So it is 5 volt, and here okay, so here we also need some ground pins. Ground pins are missing. So here what we can see is this is female connector and this is male connector of DB9, and this is female and this is male. So in the every female connector, what we can see is 1, 2, 3, 4, 5. 5 is ground, so 5 pin is ground. Our 2 pin is TX, so we can see 2 pin is TX. Okay, so here what we can see, this is the female connector pin out, and this is, we are using this DB9 is female connector. So this pin 2 is TX, right? This pin, the data we are sending from controller, it is reaching here at pin 10, and then it is T2 out. So it is TX pin, but at the receiving end it will be RX. So this is actually TX from MCU, and to the device, when the data will receive, it will be RX for that device. So it is actually TX pin. So pin 2 is TX, which is okay, and then pin 3 is RX. So pin 3 is RX. So when the device will send data, it will be RX pin for our controller. So it will come here, then out to out, out to in, then out to out. Okay, and then it will come here, and then it will be RX of our controller. So this 3 pin is RX and this 2 pin is TX. 3 pin is RX, 2 pin is TX, 2 pin is TX, 3 pin is RX. Okay, and now the 5th pin is ground. 5th pin is ground, so we'll copy this ground here. Okay, 5th pin is ground, and then 6, 7, 8, 9, which we don't need this pin. Okay, so this schematic is okay, and now welcome to LoRa. So this is 3. It is 3.3. So device, it will receive 5 volt from the input side, 5 volt from the input side, and then to the GSM, to the LoRa, it will be 3.3. So it will be 3.3, and then 3.3 come here. Okay, and now what we can see is we might have did something wrong here, because the MCU is receiving 3 volt and we have connected 3.3 volt here. So I think we have to use LDO of 3 volt. As per the LoRa module datasheet, the minimum voltage is 2.7, so we can give 3 volt to the device. So now for the 3 volt LDO, we can use this device for our LoRa module. So we have opened our datasheet, and we'll make the schematic symbol as it is in the application circuit. So we'll move here to our integrated circuit library, and then we'll add new symbol. Symbol name, we have to add this port number, okay, and now we can add this 6, 7, 8 pin. 8 pin we have to add. We'll come here downside, and okay, so Vout 1, Vout pin 1, electrical type passive, And now, okay, grid is, always check the grid before placing this pin, because at the end while doing a schematic it will create a problem. Our connection will not be done because of that grid issue. So I've changed the grid to 50 again. So V out and then pin 1, okay, and then it is V out pin 2, V out pin 2, and sense pin 3, sense pin 3, then SS pin 4, then input 8, input is 8, then again input is 7, then again ground is 6, then again enable is 5, enable is 5, okay. And now move to the application circuit. So we have to place input pin together and then enable pin here, and then output pin at other side. We'll make, press X, and then sense, press X to change the orientation, then press S again, X we have to press to change the orientation, and then we have to add this ground. So press R for rotation, and now add a rectangle, okay. And now fill with outline color, background color, okay. So to input, enable ground, SS, sense and out, and to here at the pin symbol we output 1, 2, 3 sense, 4 is SS, 5 is enable, 6 is ground, and 7, 8 is input pin, okay. Symbol properties, data set, okay, data set, and then manufacturer name, manufacturer part number, and then supplier part number, and then you have to copy it, copy the part, copy the manufacturer name, and then copy the supplier name, and copy the supplier part number, copy description, copy part number again, disable all this except reference and supplier part and reference and manufacturer part number, okay. So it is now done, and now we have to create footprint. So I'll go to the footprint, add new footprint, and then we'll copy this one and footprint name, okay. Change grid to 1.27 mm alt plus 1 to change the grid. Save it, go here, and package we can see is DFN package, DFN 8. Okay, so we have only one package here, so we're going to use this one. So there is also one option to create footprint, and we can also use this one, this feature. So we're gonna select this QFN and then OK, and now pitch, this is integer means number of pins, so it is 100. In our case it is 8. And now pitch, we can see pitch is 0.4. In our case pitch is 0.5. And with a pad width is pad width is 0.25, so maximum we can select 0.3. Pad length we can see 0.3, 0.4 or 0.5. we're gonna select 0.5. Okay, and now EPAD. EPAD length 2.54 and 1.7. 2.54 and 1.7. Package size 3.1, 3.1 and 3.1, and two by two. Something is wrong here. It has four sides are coming. Okay, so we'll first gonna save it here. So we're gonna export this to the editor, and now change the grid. We'll first change the grid here. So I think we are gonna design this footprint manually. So what we can do is we can select this 0.5, we need 0.5 pad and 0.3 pad. Okay, 0.5 and 0.3. 0.3, 0.5, and this is copper paste and mask, and this is pin 1. Okay, and this is we're gonna select this rectangular, and okay, and now press R, and okay, and the pitch we need is 0.5, so go to grid and change the pitch to 0.5. so we'll select 0.5, press Alt plus 1, and then okay, so this is 0.5, we can see. So it is 0. Look at this x and y, so it is 0, and now when I bring this down it will be 0.5. okay, and then 0.5 pitch. okay, so 4, and we need 5, 6, 7, 8. so this side we can see it is 1.7. so total length is 3.10. so 3.10, and the pad length is 0.5. we kept 0.5, so 3.10 minus 0.5, it will be 2.6. so the pitch pin to pin gap will be 2.6. we'll come to the editor, and then we'll change the grid size. user grid, and this will be 2.6, and this will be 0.5. okay, and press OK, and then Alt plus 1. we'll change the grid here, and then 5, 6, 7, 8. okay, this is done. This is now at 2.6 place, and this is 0.5. check this dx and dy. 2.6 dx and dy again 0.5, then 1, and then 1.5. it is okay. Now what we need is thermal pad. 1.7 and 2.54, 1.7 and 2.54, and this will be copper. This should have paste layer and the mask layer, top paste and top mask and top copper. And I did one mistake, so let's start again. So this is again 1.7 and 2.54. so this will be 1.7 and 2.54. so I put the values in position x and position y, so it is just a coordinate. so the pad size is here. so x is 1.7 and the y is 2.54, 1.7 and 2.54, and then this is SMD and top copper, top paste, top mask layer. okay, then clearance check. okay, so this is okay, and now we have to place it. so this is 2.6, this total pitch is 2.6, and this is 1.5, y is 1.5. so 2.6 and 1.5, half will be 1.3 and 0.75. so we'll go to user grid and 1.3, and this will be 0.75, and Alt plus 1. okay, so by doing this we'll get the exact center for this pad. so this is the exact center. okay, and now we need, so now this is center, so we'll set the coordinate here, and this will be our center. so now what is left? 3.10, the size is 3.10 into 3.10. so 3.10 divide 2, it will be 3.10 divide 2, it will be 1.25. So we need silk screen of 1.5 at both this side. So we'll use this, so we'll select silk screen and we need 1.5. So when I select here, this is 1.5. Why is this is center, and we can see this y, it is 1.5. So what we are going to do is we'll go to the grid properties again and we'll select this 1.55 and 1.55 and then press OK. And now this we can see this dx and dy, this is again 1.55. so press line by pressing I button. Okay, okay, so this is done. And now what we're going to do is we'll again change the grid size. We'll change the grid size to, let's say, 10 mil. So this is 10 mil, and now we'll just move it little bit from here, and again we'll move it little bit from here, and change the grid size to 0.1. okay, so okay, make your connection, make your silk screen connection, and so after correcting the silk screen, we can mark pin 1. So this will be our pin 1, and we'll change the size to 0.5. Change to 0.5, 0.5, and then we'll have this pin 1 marking. So it is then 1 2 3 4 5 6 7 8, right? And now, so this is exposed pad. When I go to datasheet again and check the pin marking, so the exposed pad, it should be connected to the ground, and the ground pin is pin 6. Ground pin is pin 6. So what we are going to do is we'll change this to pin 6. So pin 6 and pin 6, these are ground. Okay, so it is done. And now we'll go to the symbol properties again, and we'll extract footprint. So select this one, and it is done. So integrated, and this is our part, and this is input. So again there is a grid problem that we discussed before, so I check it to 50 mil grid size. So again I have to check the grid size. So here the grid size is 10 mil, so this is the issue. So we're going to delete this wire and to make the reconnection again and change it, then press W. Okay, capacitor, then 100 UF. We need 100 UF and then capacitor. Then we need 22 UF. Okay, so we have completed our schematic for this 3 volt LDO. So this is 3 volt. So we are going to add node here. So press T, then 3 volt LoRa output. So this is for 3 volt LoRa, and so 5 volt will give 3 volt here, and then this 3 volt will come here to the LoRa module. So entire signal will also be 3 volt. So the ground connection and everything looks okay to me. So one thing is left is annotation. So we'll select annotation, and this time we'll keep existing annotation, and now annotate. Okay, this is done. Now save it. So we have verified our LoRa module. So power schematic 232 LoRa verified, miscellaneous no need to check, and then GSM is also working on 4 volt, but the signals are at 2.8 level, so it can be read by the controller. So this is a ground, everything looks okay to me, and okay, so this is done. So and now MCU is left, MCU DCVDD, and now for power we can check this is 3 volt. So we're going to change the power connection by adding 3 volt. Okay, so this will be our 3 volt. Okay, so now the MCU looks okay, the connection looks okay, everything is checked. We'll keep existing annotation, we'll check again, looks okay to me. And now we have completed our schematic, and now in our next video we will work on the DRC error, and then we'll work on some other part of the circuit like PDF generation of the schematic. So before that we have to work on this component. So for most of the IC I have set the value like manufacturer power supplier details, but it is not with the capacitor and resistor, so I have to correct that, and then we'll generate our BOM. So see you in our next video. Bye.